All right, so yeah, I will be talking about the limits of L2, or the alternative title would be why the Gnosis Chain has chosen to not be an L2. And kind of just immediately as a kind of to set the context, we do think L2s are important. L2s are great. They serve specific needs, but we do disagree that L2s are the only solution, or kind of you can do everything with L2s, because they do come with trade-offs, and yeah, that we want to explore. So again, currently the narrative is, or at least in the Ethereum world, the narrative is, yeah, we have Ethereum, that's great. Of course, it has also issues, it doesn't really scale. So we are doing L2s, and kind of the almost dominant narrative is just Ethereum and a bunch of L2s. And yeah, that's how we can scale. And again, in this talk, I want to challenge this assumption and say, yes, that's part of the solution, but we need more. And specifically, and this will also be a topic of the day, there are significant advances in, for example, trustless bridges or trust minimized zero knowledge based bridges between different L1s that, kind of in our view, change the situation to say we can have a more richer solution than just kind of Ethereum plus L2s. If you talk about L2s, then there would be a very obvious criticism, and that's the current state of L2s. Despite right now the most prominent roll-ups securing billions of dollars, at the moment, while the research is real, the work is real, but the actual implementation of them, I would almost call them memes, because they do right now not yet provide the security guarantees they promise. So there's this great site, L2beat, that exactly lists the current state and the current risks. So at the current moment, just those two examples, Optimism and Arbitrum, they again do not have the guarantees that an L2 is supposed to have. So instead, a multisig or even can immediately take away all funds. A sequencer can, in the case of Optimism, sequencer can produce a incorrect state, and it can be not challenged. So that would be the easy criticism, but that's not what this talk should be about. We want to discuss, like, assuming all those things are fixed, and assuming kind of assuming L2s are delivering what they promised. Even then, and kind of those are the things I want to discuss in the talk. And here, and starting with how the idea of L2s evolved. And initially it started as L2s are temporary spaces. So meaning you start on an L1, you have your L1, kind of the assets are on the L1, and then you deposit into the L2. You do all kind of transactions, and eventually you settle back onto the L1. And this is kind of the idea of liminal spaces. So spaces you don't really stay in forever. You kind of just pass through, but eventually you leave again. Again, that was the initial idea of rollup, and that's kind of also where the name comes from. Do a bunch of transactions, you roll them up, so in a way you compress them, and you only then eventually have the compressed state settled on the L1. So let's explore this original idea. Of course, that means the L1 is still heavily, or is still used, because again the idea is you start in the L1, you do stuff in the L2, but you go back to the L1. So So you get some scalability. Obviously, you can get significant scalability improvements, but essentially there's a ratio between how many transactions can you do on the L2 until you settle again. And kind of just one very easy kind of example to make clear why this approach doesn't lead to infinite scalability is if we just look at Bitcoin, some people claim, and that's an extremely naive claim, if you would just have Lightning, then Lightning would lead to infinite scalability. But if you just do very, very extremely oversimplified math, and you calculate just if every person on the planet would want to use Lightning, and you again make a extremely simplified assumption that they only need to do one opening transaction, kind of to open a channel when they are born, and 80 years later when they die, kind of the channel is closed. Again, extremely simplified kind of assumptions. Even then, the Bitcoin L1 couldn't handle that many transactions. So again, it's simply false that a technology with as Lightning could scale, for something like Bitcoin to be used worldwide, because again there is a connection to the L1, and we can do similar calculations for Ethereum. So that is the number of transactions L1 Ethereum has been doing and can do. So it's pretty much capped. So Ethereum has essentially reached its limits since a few years. It's pretty much capped at 1.25 million transactions per day. Of course, kind of depends on the gas costs. So if you do more gas expensive transactions, you can do less, and so on. But roughly that's the limit. And in the Ethereum roadmap, at least for the next 3 years, there is nothing that would significantly change this limit. So maybe the gas price can be spiked up. The gas limit can be increased a bit, but fundamentally that's the limit we have. So again, just to do a few calculations, super simple examples. Just 10% or if we assume kind of L1 is the settlement layer where things should actually be stored, then even kind of to just say, even if we say just 10% of the world wants to have an ENS name, that would take 2 years kind of to just do those transactions. So again, that's clear that it's not really scalable. Or another example, if we would assume, again, Ethereum should be the global settlement layer, so we want stocks eventually be tokenized and settled on Ethereum. And we even go away from the idea that they are traded on Ethereum, or that people individually are kind of hold their stocks on Ethereum kind of just for settlement. And we say, okay, worldwide there are 45,000 listed companies. That would mean we kind of just have 30 transactions per day per company. So even just for settlement, just for kind of settling between large brokers or kind of moving between L2s, it wouldn't work. And of course, Ethereum is neither just trying to do ENS or just trying to, Ethereum is doing much more. So again, basically the point is, if you go with this approach, L2 is a liminal space, but eventually you settle back on L1, then L1 can still be a very significant bottleneck. And those things are those numbers I showed you at the end of the day are represented in fees. So right now the fees of L2s are still proportional to the fees on L1, and roughly roundabout it's currently a factor of 10 to 15. So L2s are 10 to 15 times cheaper. But again, if we see sometimes transaction fees on Ethereum spike. Well, then again they spike in the same way on L2, and they can easily be above $1 on an L2. That's not the average, but on spikes that can happen. And of course, there are plenty of applications where dollar is totally unacceptable. And actually, we are just to mention one example. A project we are working on is let's see if I can show you this nice credit card. So we are working on a project where we actually kind of have a credit card where the individual transactions are settled on the blockchain, and for such a project, obviously you need sub-cent transaction fee, so simply not doable on an L2 on mainnet. 4844 will change that, or will to some degree make L2s cheaper. But again, even if they the expectation is fees will still be not in the sub-cent range. Another kind of limit of this approach is the idea is your ability to exit to L1 is important for the security guarantees, but that means if the value you hold on the L2 is so small that it's let's say $20, but your exit transaction to L1 is more than $20, then kind of that value is at risk, or at least cannot necessarily, or it's just economically not viable. So it doesn't really have that exit promise, because you can't really make use of it. The next argument is there are applications where kind of this general concept works. So you deposit, you do all kind of transactions, but eventually you withdraw. But there are other applications where it doesn't really work. So if the state on the L2 is very rich, so on the L2 you have, I don't know, kind of a large web of trust. That is a project I also kind of working on, Circles UBI. Again, with this large web of trust, or just generally also a project like Lens protocol. If the state that is generated on the L2 is very complex, this concept of rolling up a bunch of transactions and then again settling them doesn't really work, because you don't really have this compression effect. Also, kind of if you mint a bunch of, or kind of thousands of NFTs, POAP would actually be an example. It's not really. I mean, you don't really have any gains from this idea of compression, because the settlement on the L1 would be as expensive as immediately doing it on the L1. So not any application can be rolled up. Cool. So that was the first part, saying kind of if we assume L2s are temporary spaces, but now the discussion has evolved, and now we are saying, well, maybe you never have to leave the L2. Maybe you can just stay on the L2. So the idea of rollups as permanent spaces. So let's discuss that. And I think it's just this tweet just captures that idea well. What if you never have to leave the L2? Just be on the L2. You own nothing on the L1, and you will be happy. So, a few things that might go wrong. So, in essentially all L2 or in all L2s that have been proposed, the idea is to have a centralized sequencer that can do the block production. And yes, there are some checks and balances. So there is the idea that you can, if the sequencer would kind of ignore you, there are ways to force a transaction, or usually force a transaction via L1 to exit. But it's really important to understand that the sequencer kind of has by default the power to decide what transactions to include. So that means a sequencer can, without any problem, kind of say, well, you as a user, you are out. So, or your transactions will be ignored, or a specific application pays a higher fee. So it's very easy and kind of also kind of to do the Apple App Store model where basically Apple decides, well, we always take 30% cut. That's absolutely something a sequencer can do. Yeah, another example is, yeah, we found this meme on Twitter, select all the base chain validators. Yeah, another example is I mean, or base, the L2, yeah, kind of coming up from Coinbase makes this very obvious. And also to be very clear, I think it is a good move from Coinbase. I totally think users having their assets on an L2 of Coinbase is better than users having their assets on kind of just a centralized exchange. So again, absolutely applaud the move from Coinbase to do that, but still, you should certainly not mistake this this L2 for a credible neutral platform. Just one example that if they wanted to, they could easily yeah, kind of if there are different dexes, they could have one dex that's the preferred dex and that shares kind of the liquidity or has a deep integration with their centralized exchange order book, and then yeah, good luck competing with that dex as another dex. So again, it's simply not a neutral platform for applications to build on. Coinbase can absolutely pick winners here. Another one is of course the risk of yeah, regulation. We saw that even on Ethereum, which yeah is supposed to be very decentralized, even on Ethereum, we ended up in a situation where in October, yeah, almost 80% of the transactions, or sorry, of the blocks were censored, and yeah, and that's absolutely possible that an L2 operator might get the legal requirements to yeah, to censor, to exclude specific users, or even might have the requirement to yeah, KYC all users and only accept users from well that went through KYC. You might think if you look at the graph, the problem is solved or is about to be solved. And yes, I mean the trend looks good, but I know how the sausage is made, and that this is very fragile. So kind of essentially, it's three entities, and we are one actually that produces the green blocks. And to be also very or kind of, I mean that's simply how it is. If even our legal analysis would be different, and kind of it would say currently we think it's totally legal for us to do it. If our analysis would say we can't do it, then we would, well, need to shut down the service. So the veil of decentralization is thin even on Ethereum. Yeah, now comes another important argument. If we think that the L2s are permanent chains, then that means you are also issuing assets natively on that L2, or the idea, it's less clear if you have assets natively issued on an L2, why you need the L2 at all, because the kind of the promise of the L2 is to have a secure bridge to the L1. But if the asset is native on the L2, it seems less needed. Or to put it in another way, on a chain like Gnosis Chain, if there are assets that are issued natively on this chain, the regular criticism of a not L2 doesn't really apply, because so the criticism goes, the validator set of Gnosis, it is over 100,000 validators, but still kind of just quote unquote, let's say 15 million in staked locked is much smaller than that of Ethereum. So the argument goes, assets are less secure. That is false. That is false if we are talking about not bridged assets, because if we are talking about native assets, it is not the case that a majority of validators could steal this asset. So the thing is, if you actually are able, or kind of the issuer of the asset is running a full node, you are running a full node, then even if the majority of the validators would kind of start to attest to a malicious state, a full node would not accept a malicious state. So basically, the argument is there is nothing more secure than an asset natively issued on the chain. Then you always, if you run a full node, you will not be fooled, or your full node will not accept a malicious state. And kind of just to mention a few examples of assets natively issued on Gnosis Chain, for example, we have the Circles UBI project, but also Monerium. They actually they are a euro stablecoin that is actually considered as e-money, and they issue it natively on Gnosis. There is this Backed project that has started to issue tokenized stocks. They have started with S&P 500, Coinbase stock, and those are, I mean, they do it also on other chains, but also they issue it, so I think Ethereum and Gnosis, but they issue them natively on Gnosis. So again, the question of how secure bridges doesn't apply, because the asset is simply native. And again, with USDC, we also see that they started on Ethereum, and initially assets were bridged to other chains, but now they also started to issue assets natively. Another argument is the question of, I mean, my very initial slide was the current state is L2s are upgradable, and therefore they don't really kind of provide the guarantees they are supposed to guarantee. They are supposed to bring. The question is, can L2s actually become not upgradable? And that will be challenging because L1 Ethereum is still in heavy development, and kind of that was a quote, or kind of I copied it out of a post from Danny Ryan. So this idea of Ethereum ossifying or kind of stabilizing, and essentially the acknowledgement this will likely not happen in the next 5 to 10 years, or pretty clearly not happen. Maybe it never happens. So what does this mean for an L2? For an L2, it means there is some form of risk that that an upgrade or a change in the L1 will require also a change in the L2. And kind of if you that kind of means you might need to have this upgradability, and that again might mean you need to compromise with this trustless promise. And kind of just one example, on the right there is a kind of Ethereum roadmap. Don't want to go into details, but there was one project, Snapshot X from Starknet that tried to do kind of this voting in an L2. So you have your assets on the L1, you kind of do the voting in an L2, and with Merkle proofs you can then essentially trustlessly bring the result back to the L1. There is, on the roadmap of Ethereum, there is the idea to change the internal data structure of Ethereum from Merkle trees to Verkle trees, and that change would simply break this model. It would actually, after we have Merkle trees, it would actually make it easier to do it, because in Merkle trees you can make proofs more efficient. But still, it would mean if you deploy it today and say kind of this is our governance mechanism, yeah, you kind of already have the danger that in 2 years this will break. Okay, so now we talked about the shortcomings or trade-offs. What do we have, kind of what is our proposed solution? Yeah, not a big surprise that if I come as speaking for Gnosis Chain, that kind of we suggest other kind of to have additional L1s. And the important difference is that we can have trustless or trust minimized bridges. And essentially, we are here borrowing from the Cosmos model of having a bunch of L1 chains that are connected via light client or trust minimized bridges. I think a year ago, or maybe 1.5 years ago, that was not really, or kind of there was not really the assumption that it's possible to build those bridges for Ethereum and for the Ethereum consensus layer. But it turned out it is possible, and in fact, several teams are now working on it. And actually, we will have a panel on this later today. So yeah, we are proposing to have the advantages of the Ethereum stack. And just going one slide back, we are actually quite proud that you can use, or that Gnosis is that deeply integrated into Ethereum that you can just use your regular Ethereum node, Ethereum client. It's absolutely the same software, and you kind of just use the network flag Gnosis, and you are you're running the Gnosis chain, kind of just showing we are really deeply integrated into Ethereum. So yeah, we are proposing we should have those. We should simply have more secure L1 block space, have them connected via standardized and secure bridges, and complement those different L1s with rollups on top. Yeah, the name we are proposing is the Ethereum verse, and again, it combines the ideas of Ethereum and rollups and this EVM chain, EVM approach with the Cosmos ideas. So in summary, L2s are great because what they essentially do is they take the existing L1 block space, secure block space, and leverage it to create more of it. But this leverage effect, we would argue, is limited. So we cannot stop investing in decentralization and neutral block space. So again, the whole sequencer argument on chains like Ethereum and absolutely on Gnosis chain, it's absolutely crucial to us that also the block production is as wide as possibly distributed to really provide those, this credible neutrality, credible neutral platform to build upon. Yeah, I think that's it. Thank you.
The example of snapshot, doesn't Gnosis also have the same dependency issue unless you're going to start maintaining your own EVM?
Yeah, so I mean the difference is well on a or kind of Gnosis will also, or the argument is L2s will need to have upgrade mechanisms. Gnosis chain also has an upgrade mechanism, but that is kind of the upgrade mechanism on an L2 is usually a multi-sig, 5-6 people kind of agreeing to something. The upgrade mechanism of an L1 is thousands of validators needing to, or kind of a hard fork essentially, where you need to, where you need to convince a lot of people or a lot of entities at the same time to make this upgrade. And I would argue that approach, that's of course also the approach Ethereum has chosen, provides those checks and balances, and if just one party goes ahead and says we are proposing that and others don't follow, then it won't work. So I would say that is an upgrade mechanism that does provide or that still keeps this promise of neutrality.
Okay, so the upgrade mechanism is centralized, but you'll still have the same dependency issue in 5 or 10 years if the EVM changes.
For the bridges, or
just the EVM, like the EVM itself, right? So if apps are developing for the EVM of today and Ethereum is changing in the future, Gnosis Chain is also going to mirror those, right?
Yes, yeah.
But I think your question is about the L2 usage, or that was his point, right? Whereas
maybe we're focusing on different areas.
Correct. Yeah, I think you're talking about the L2 upgradability on mainnet versus you were just talking straight Gnosis on L1.
Okay, I mean, I think Ethereum. I think the Starkware example is a little bit it is, I guess, an edge case, but it's an important one. So I mean, usually, of course, the promise of Ethereum is that applications that build on top or directly built on top are never affected by an upgrade, or that certainly is a promise. I think with L2s, and I would consider this Starkware example. I mean, it's not. I mean, they're kind of trying to. They didn't build directly smart contract on Ethereum, but they're kind of trying to use it, and it feels like this guarantee that Ethereum usually gives to say if you deploy here you will be fine. That doesn't necessarily hold true for things you can build in a more abstract way on Ethereum than direct smart contracts. So I would say probably if you build on Ethereum or Gnosis directly with smart contracts, you should be fine. But yeah, the example is if you use this Merkle proofs, or use the internals of how Ethereum is working, then apparently there's this risk. And yes, it would also be the case for Gnosis.